Great, good morning. This is Thursday, the 17th for ACA. Our warm-up is, yes, still some order of operations because we're still struggling with it quite a bit. So please copy down that warm-up, and then we want to talk about classifying. We're going to start spiraling back to stuff we learned at the beginning of the year, classifying the number like the funnel, remember that funnel thing? Okay, I have it in my room as the rational, integral, whole numbers, natural numbers, figuring out where that would fall. So if you're at home, pause and play when you are ready. Okay, my class, what is a helpful tool to help us solve this correctly, class?
Gemma.
Okay, we're still getting people not even use that checklist whatsoever. So the G stands for grouping. So let's do that first. 9 minus 7 is 2. I'm rewriting everything else. 5 plus 2 times 3 minus 12. Okay, am I done with grouping?
Yes.
Yes. Next is exponents. Do I have any?
No.
No. N stands for
Multiplication
or division in this case. Multiplication. 2 times 3 gives me 6 plus 5 minus 12. Okay. Addition and subtraction. I have both of them. The rule is left to right. So 5 plus 6 is 11 minus 12 is negative 1. Negative 1. So mistakes that we're still seeing on the quizzes from yesterday, pause, thank you, is like this, 10 squared. Actually, no. It was like this. This isn't the whole question, but part of it was 9 plus 1 squared. Okay? Order of operations. This, again, was not the whole problem. This was part of it, but a lot of mistakes were happening on this. The rule for this is what piece do I do first? You do the 9 plus 1. We had some people square 9, square the 1, and then add them. You have to finish what's inside. So class 9 plus 1 is 10. And then this caused another set of problems. Jackson, 100. It's 100 because 10 squared is the same thing as 10 times 10. I cannot tell you how many people put 20. Okay, it is 100. Okay, it was supposed to have all those problems fixed, but then we're still there. I'm just looking at it. Okay, proud of that. All right, let's go back to the second part of my question, though. The second part was how would we classify that number? So before we classify it, let's review what each of those pieces mean. Okay, so we always use that funnel. Do y'all remember the cute little phrase so I can remember the order that they go in? No. We're going to the classification part. Do y'all remember what was the cute little thing? No, for classifying. Run in with numbers was something I said. Y'all remember that?
No, I
Great.
know.
Okay, that's how you know the order, like from the most specific to the least specific. Let's review each one. R stands for rational. What kind of numbers are rational numbers? Everything. Okay, so that means it includes negatives, positives, decimals, fractions, 0. Weird. Huh? Percent, yes. At the time we hadn't talked about percent. Percent would go in there as well. Okay. I stands for integers. So what makes it through?
Negative, positive, 0.
And 0. Very good. Okay, percents are not going to make it through because percents are out of 100 and they're either fractions or decimals once you actually turn them into it. Okay, W stands for whole. What makes it through? And 0. The negatives get stuck. 0. And then lastly, N stands for natural, which would just be all the positive whole numbers. Now remember, the only difference between whole numbers and natural numbers is one number, and that one number is 0. And the way that you can remember that whole numbers have 0 is because it's in the word. The 0 is in the word whole. Okay, so now let's classify -1. put it in the top of the funnel, would it be considered a rational number? Yes. -1 is a rational number. Would it go down one level to integers? Yes, it would. Okay, would it go down another level? No. What stops it from going down? That negative sign. It's technically, yeah, okay. It's that negative sign. Yes, I know. You're right. Okay, so if I was asking for the most specific classification, we would say that it would be integers. But if I listed all the classifications, it would be rational and integers. Okay, let's do another number. If I did 1024, okay, if I put it in, is it rational? Is it integer?
Yes.
Is it a whole number?
Yes.
Is it natural number?
Yes.
Most specific would be natural numbers. Okay, last one, if I did 9/3. 9/3, rational?
Yes.
Does it go down to integers?
Yes. No.
Ryan, why?
Oh, because it's technically 3.
9/3 is the same thing as, Lord, 9/3 is the same thing as 3. So that actually goes all the way down. Remember, fractions were kind of tricky, but you're going to say, no, I'm better than you. Okay, don't know.
Okay.
All right, are we good with that?
Yeah.
Okay, any questions before we move on? No. All righty, that maze from yesterday, here was the key. I'm glad several people were at tutorials, asking questions, getting it checked. Were there any problems you needed me to do?
Oh, you didn't do it. I went.
Okay, remember we're recording. Guys, we are recording, and I would appreciate if we could say, sorry about that, guys. We are going to start on a new lesson. This is some of my favorite stuff, solving equations. Now, just to quickly review, is it at the top of this? It is. Expressions versus equations. What do we remember saying is a difference between expressions and equations? Yes, right.
Expressions don't have answers, and equations have answers.
Exactly. Okay? Expressions don't have answers while equations do. So I'm going to put some more mathy explanations, definitions, just please right along with me. So an expression, you can define it as a combination of numbers and operations. Okay, and that's a true statement. 4 plus 5 is an expression. It has numbers 4 and 5 and then an operation of plus. Sometimes you can also include unknown things, and those unknown things are called
Variables.
variables. May include variables. Variables. Yes, sir.
Do you have any numbers?
Yeah, in the back of my room. Alrighty. So a numerical example is going to have numbers in it. Does anyone want to give me an example yet? 4 plus 3. I'm going to go ahead and put on a -12 on there. Is that a combination of numbers and operations? Yeah. You would have a negative. Okay. And then an algebraic example. Algebraic usually just means that there's some sort of variable, some sort of unknown. So Miss Lyle's going to make one of those an x. 4 plus 4. 4 plus x minus 12. Okay. When it's algebraic, right now, do I have one set answer that x has to be? No, I can plug in anything. Okay. But what we're going to talk about today with equations is when variables can only have one value. Yes, sir.
How would you know what is what?
Well, again, as an expression, you can plug in anything. But as an equation, you'll see that there's only one set answer. So with equations, it's a mathematical sentence, showing two expressions are equal, showing two expressions that are equal. Pause and play if you need to. I know it's a lot of writing. So for example, 5 plus 8 equals 13. Does it have an answer? Yes, it's an equation. It has an answer.
So like 5 plus x equals 13.
Okay, so yeah, we could do 5 plus x is equal to 13. Now, can I plug in any number for x?
No.
No, it has one set
So
value.
what equals
In this case, x would equal 8. And we'll get into that in just a
So
second.
is it just going to be
Okay, pause. So how are equations and expressions similar? They both have operations. They both have, we just said operations. They both have numbers. Okay, great. They both have numbers and operations. Yeah, hashtags. They have hashtags. They have numbers and operations, may include variables. I'll change colors here. May include variables. It may include variables. Pause and play if you need to at home. Whereas their difference is, what's the difference?
One has an answer, one doesn't.
One has an answer, one doesn't. Okay? Equations have answers slash, you could also say like equal signs. Okay? Alrighty. So, I think we've talked about that quite a bit, and now we're sort of going to transition into talking a lot about equations and how to solve for equations. Right now in 6th grade, we're mainly just going to have one-step equations where you just need to do one thing to figure out the value of x. As you grow older, like in 7th grade and 8th grade, it gets more complicated. So this is just sort of us setting the foundation. It's not going to be too crazy. A lot of times y'all will be able to just see the answers because you're like, oh, what plus 3 equals 5? I know that answer. But because I miss Lidl, it's going to get spicier. We're going to throw in decimals. We're going to throw in fractions. So right now, you want to do the stuff that I'm going to show you. It's going to seem like it's overdoing it, but it's going to help you when Miss Lidl makes it spicier. Okay? So it might seem really tedious what I'm doing, but again, it'll help set a very solid foundation. Of course, I like to model things because sometimes we're visual learners. And so I'm going to start with this first one. This little triangle with a stick, it's supposed to represent like a seesaw. Okay, with equations, because the two sides are equal, we want to keep it balanced. And we use that sort of model a lot when we are modeling. Okay, so to model x plus 3 equals 5, I would start with putting the equals in the middle because that's where my balance point is. Then using the models that we've talked about, like those algebra tiles from the previous, we're going to do one set on one side and the other set on the other side. So starting with the x plus 3, remember the x is one of those long little bars, and then 3 little tiles. Y'all remember that?
Yeah.
Yeah. Okay, on the other side of the balance, I'm going to have 5 little squares. 1, 2, 3, 4, 5. Okay, right now it is balanced. X plus 3 is equal to 5. Now to solve for x, I want to get it by itself on this picture, right? Okay, so to get x by itself, I'm going to do what on this side? I'm going to take away, I'm going to subtract those 3, but now, I'm off balance. What do I need to do to the other side? Take away 3. Yes. My kids are running into airplanes right now. Okay, so when all is left, what's left is x is equal to 2, because I've taken off those other 3. Okay, I love the balance image the most, it really makes sense. Okay, but we have a few others that we can do. Okay, this bar model, with expressions, we usually just have one long bar, but with equations, we have 2 because we have the 2 sides of the equal sign. The one that's the full, this full length one right here, that's always gonna be the number, so the 5 is gonna be down here. And then it doesn't really matter which one's which, but we can put X and 3, because that's how we bar modeled it, is we did X and then we added on 3. X plus 3 is equal to 5, so X has to equal 2. Okay, and then this last model is very similar to the seesaw, except it doesn't have a seesaw. It has the equal sign in the middle. I have my X and 3, and that's equal to 5. This one's like, I call it the desk model. Okay, but you would solve it the same way. You would take off 3 to get X by itself. You would take off 3. Take off 3 to get it by itself. Okay, you can see any version of these on tests and quizzes, STAR, and all that stuff. All right. And then of course, y'all's favorite word problems. Let's just write a word problem together. What could X plus 2 look like? Do y'all want me to do one first? Or y'all want to try it out with mom? What? Okay, that's not a word problem. Yes.
Sally has X amount of apples and gets 3 more.
Great. Sally. Okay. Sally has X amount of apples and gets 2 more. And gets 3 more. Now she has 5 apples. How many apples did she start with?
3 apples.
No.
2.
Oh my gosh. Okay, we're gonna pause because that's a lot of writing. All right, next one. Okay, the first one we did addition. I'm of course going to show you what subtraction looks like as well. So the equation X minus 2 is equal to 8. This little triangle we say, again, it's our equal sign. Let's go ahead and model 8 over here. 1, 2, 3, 4, 5, 6, 7. Thank you. Okay, and then the X minus 2. Okay, hopefully you remember with the X is that long stick. And then for minus 2, we're going to do negatives. Very good. So we're going to have 2 negatives. I'm going to put that negative symbol in there. Okay? So my goal is to get X by itself. Okay? This one, it takes a little bit of adjusting. If I have 2 negatives, how did we get rid of 2 negatives before? I add 2 because that makes a 0 pair. So I'm going to add 2. I'm doing it in a different color. If you have a different color, do it in that. But somehow you're going to add 2. Maybe if you want to put a plus sign here. But, now I'm off balance. I can't just add 2 on one side. I'm unbalanced, so what do I need to do? No. Take them add 2 to the other side. Okay, I'm going to add 2 to the other side. Okay, again, I'm going to show that I'm 0 pairing these out by circling them. Sorry, my board is so wonky. I really wish I could change it. Okay? And I'm left with, there's no 0 pairs on this other side, those were all positives. I'm left with X is equal to 10. And is that true? If I plug in 10 into that equation, 10 minus 2, is that equal to 8? Yes. That is the beauty of this unit. You should never get anything wrong because you can plug it in and solve it and check it. Okay? Again, on the bar model, it's equal to 8, so the whole thing is going to be 8. The bar model is going to have an X, and then I'm adding on to it what? 2. No. It's negative 2. Oh, wow. Okay? It looks a little weird. You probably won't see these too much.
Is it because it's minus?
Yes, exactly. Okay? And in order for that to be true, it would be 10 and negative 2 because of some 0 pairs. Again, just real quick, X, 2 negatives. And then 8, 1, 2, 3, 4, 5, 6, 7, 8. To get x by itself, we need to get rid of those negatives. To get rid of negatives, we add 2 positives. We add 2 positives to create 0 pairs.
Yeah, no,
No, we have
to
2
make
pairs. Okay. Okay, and I'm left with x and 0. Okay, let's do a word problem, like a story, not just literal words. Lucy, you want to try it out? Okay. Lana, try it out. We're in a lesson. Yes. Luke, Mara, try it.
Okay, so I'd like to do this problem.
Correct.
Tyrone has 8.
Pokemon card.
Okay, we're gonna keep going.
Pokemon cards.
Okay.
And then he takes away 2.
But that's not gonna represent that, because if I start with 8 and take away 2, that's gonna give me 6. That's not is what happens. Okay, so let's start with Tyrone is starting with how many? Do we know how many?
Yes.
It's starting with X amount of cards. X amount of Pokemon.
Okay, I messed that one up.
Pokemon
Tyrone.
cards. Thank you. Okay, he gambles 2 away. He gambles and loses. He gambles. He gambles 2 away.
A rare Pokemon.
He's left with He's left with 8 cards. What's my question?
How many
How many did he start with? Awesome. How many cards did he start? Okay, you can write that down. I would love to see you write that down.
How many
Pausing and alrighty. So, we've sort of done this a little bit. Solutions to equations. So let's underline the word solutions real quick. Oh, not like that. Solutions. Solutions in the real world. How have y'all heard solutions before?
Like
They
solve something. Okay. Okay. I didn't say what you said. Okay. Solutions to equations. What a solution is values that make the equation true. Okay. Solutions. It might say list all the solutions that make this true. You say which values of x make it true. When you replace a variable with a value that results in a true sentence, you solve the equation. That value for the variable is the solution. Okay? When we write our solution, we always want to say like x equals blank. You're always going to define, it's not defining your variable, but you're giving the solution. Okay? Because when you'll get into higher math, you're going to have multiple variables in your equations. We might say x plus y equals 10. So you have to say, okay, x equals this and y equals this. So we got to practice our solutions. X equals blank. P equals blank. Okay? So in this equation, 2 plus x equals 10. What value can I plug in to make that true? 8. So my solution is 8. Okay? 8, the solution to the equation is x equals 8. Try that next one. 18 is equal to 6x. Be careful what operation is happening. What could you replace? And what is your solution? What value could you plug in? Could you substitute it? What value could you plug in to make that true? What did you get? 12? Okay, so pause. What operation is happening with 6 and x? Multiplication. So Jackson, you want to try that one more time?
So it'd be like times 3.
Very good. I would replace it with 3. So my solution solution, Jackson, what would it be?
An x equals times 3.
It would just be x equals 3. Okay, because it's what are you replacing the variable with? X equals 3. Okay, so go ahead and solve that one. Write the solution. X plus 7 equals 13. Write your solution. I'll give you a second. I'll pull another stick. What plus 7 equals 13? Natalia, what value makes that true? What could we add to 7? What plus 7 gives me 13? Very good. So I would say my solution is no. Equals 6. You had just said it. Yeah, we followed that. Okay. We can represent solutions of our equations on a number line. Okay. What goes on a number line? Numbers. Okay. Miss Lytle will always put like 0 on the number line. It doesn't have to be in the middle, but I always like to put since it's 6, we're gonna go towards the positive. So I'm gonna put 0 here. I'm gonna put what's a number bigger than 5? I'm gonna put 6 here, and then what can I put over here? 12. I like 12. Okay. So I put numbers on my number line, but I haven't said which number is my answer. To put a number as my answer, I just put a nice juicy dot. Juicy. Okay, some of y'all, I'm just saying from experience, do not be the child that does this thing where you go, no. It needs to be on the number and it needs to be filled in. In a few weeks, there's going to be a difference between a filled in dot and an unfilled dot. So, I will get there, but right now, let's not make it too crazy. Okay? Okay, so what plus 7 equals 13? Locate that value on the number line because the solution is equal to 6. We make our dot completely colored in. This is going to change in the future when we get to inequalities like less than, greater than. This is going to change when we get to inequalities, so make sure you have an understanding. It's just one dot filled in, nice and juicy. Okay, so go ahead on your own, try out number 2. -8, what operation -8? Times W equals 32. Take a second, put your solution, and try and graph it out. Okay. Lana, what did you get? -8 times. Okay, so think -8 times what gives you positive 32? Let's break it down. 8 times what gives me 32? 4. But if I do 4, signs would be different. Negative. That's on a negative, so it has to be
-4.
It needs to be negative. W equals -4. Okay. Again, if in doubt, check it out. When in doubt, like solve it out, whatever little rhyme thing you want to do. -8 times -4. Signs now are the same, so positive again, positive 32. You can always check equations. That's the most amazing part of this. Is you should get 100 every single time because you should be able to check your work. Okay. To plot this, again, I always like to have a 0, but my solution is what kind of number? It's a negative, so I'm going to put 0 on this side. Okay. I'm going to put like -4 in the middle. I can put
16.
-8.
Let's put -8.
Oh, I did like 0 in the middle and the negative. So your answer always has to be in the middle?
No, but I will always put it in the middle.
Like,
I will always put it in the middle. As long as it's on the right side of 0, I don't care. Okay? Alrighty. Another kind of question. It says determine if the given values make the equation true. Okay, so it's sort of 2 parts. It says 7 plus 8 equals 10. And it wants to know, are 3, 13, and 17, do they make it true? How do we tell if it makes it true? You plug it in and you solve it.
what do you mean?
So let me show you. Okay, I'm going to replace A with each of these values. So 7 plus the first value is 3 is equal to 10. Does that work?
Yes.
Yes. So 3 works. What if I did 7 plus 13 equals 10? I'm just replacing A with that next number. Does that work out?
No.
No. What about 7 plus 17? Is that equal to 10?
No.
No. So which value is my solution?
3.
Let's try that one more time. My solution is A equals, yes, I do. That's why I said it right above. Okay, try it on the next one. Ready, set, go. Again, where that semicolon is where it's split. Ryan, what did you get? Which one do you think makes it true? Which one can you eliminate, maybe?
The one that makes it true is called.
The bottom one makes it true, and those are incorrect. So, M equals 11. Very good. Y'all good with that?
Yeah.
All right. In that last one, again, we've done a problem like it, so now is your chance to try it. I'll give you a minute. Ready, set, go. Try out all the models. If you forgot how to model, flip back to that first page. Pause and play when you're ready. Okay? Looking at that, looking at my little balance, I have x and -1 on one side and then +4. How do I get rid of that -1? How do I get rid of this negative? Add a positive. If I, now I'm unbalanced, so I need to add another on the other side. I want to get rid of the 0 pairs. Do I have any 0 pairs? Yes, so that goes bye-bye. And I'm left with x is equal to 5. Plug it back in. 5 minus 1, does that equal 4? Bam, yes. Yeah, go for it.
Cameron has X sisters, but last week Sarah died of cancer. Now he has 4 sisters. How many is it?
Okay. Sure, it's very sad. I do not encourage you to do that kind of stuff, but it does work. Let's move on. Yes? Okay, we're going to keep going because there's a lot of packet left. Honestly, for the rest of the packet, you should be good. I'm just going to fill in these last 3 blanks. Let's work through a few more examples. You should always check your solution. That is a big thing. You should always check your solution, okay? You can check if your answer is correct before you even turn your scantron for your quizzes, for your tests into Miss Lytle. Glory's with me? Awesome. If a scale is balanced, that means that it has blank amounts on both sides. It has equal amounts on both sides. So we can think of the center of our scale as being our, what do we say? That triangle is my it's in the seesaw. That's my equal sign. Okay. I'm just honestly going to do a few more models because I've already been solving it with y'all. Okay, so setting it up. Someone tell me, since I've been doing all the models, someone tell me what I should draw on this. What could I draw on this? Cameron, thank you for volunteering. Okay, for this first one, what am I going to draw on my seesaw?
Right, you're gonna write X, rectangle.
Okay.
So then you add a 4 next, and you add 4 cubes.
4 cubes, very good. Are they positive or negative cubes? Very good. On the other side, I'm going to put 10 positives or negatives. Positives. Awesome job. Thank you, sir. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Again, you can always put that equal sign in there. It helps you out. It's nice. Okay. Brody, how can I get x by itself now? There's a couple ways you could do it. What's one way that we could get x by itself? How do I get these 4 guys off? Hands down. How can I get those 4 off? Pause. Camera, up here.
Like, what do you mean by that?
How can I get x by itself? What do I need to do with those? Take them away. Very good. Okay. So I'm gonna just circle these and take them away. Say bye bye. But I'm unbalanced. So Brody, what do I need to do? Not if I took 4 away off of this side, what do I need to do the other side? Very good. Take 4 off. Okay. I'm gonna take off these 4. Okay, now see what you have left, class. Salma, what do I have left? I have x is equal to, thank you, Salma. How much is left? 6. X is equal to 6. Okay? So, are we going to draw models every single time?
No.
Okay. If the answer is yes, thank you. I love it. Okay? But this model is, of course, going to show you how to get the math of it. So, we're going to rewrite that equation. Algebraically, this means mathematically, copy the equation x plus 4 is equal to 10. Copy that expression, or sorry, that equation, x plus 4 is equal to 10. It should be in the same one as Miss Weidel. X plus 4 is equal to 10. Okay, what I do next is I split right at the equal sign and I draw a line straight down. That is the two sides of my seesaw. It helps visualize. Those are the two sides. Now, mathematically, what did we do over here?
Good models.
Yes, okay, mathematically though, Brody told us to subtract 4. So that's exactly what I'm going to do. On this side, I'm going to subtract 4, but then we said, uh-oh, it's unbalanced, so on the other side. On the other side of that line, I'm going to do minus 4. Okay, y'all see that? When I have a positive 4 and then I take away 4, what does that do? It cancels out and makes 0, so I throw a slash, and I'm left with x. I'm left on this side with an x. Over here, bring down that equal sign, I'm going to do 10 minus 4. What does that equal? 6. X is equal to 6.
Can you?
Yes.
Can you also do like with the number that you have? The number that you have is those.
That's what I did. Okay? This is exactly how we expect you to write your equation. This is how 7th and 8th graders will expect you, like the teachers will expect you to set up your work just like this. Okay? You write the equation, you show that you're doing something to both sides, and then you get your final answer. Always check your answers by working. Check your answers by plugging it back in. So we started with x plus 4 is equal to 10, and we say that I think that x is equal to 6. Plug it in. 6 plus 4 is equal to 10. Does that work out?
Yeah.
Bam. Good. Okay. Let's do another one real quick. X minus 3. I'm starting with an x. And then how do I do minus 3?
Negative
3 negatives. 1, 2, 3. On the other side, I have it equals 6. So that's going to be 6 positives. To get x by itself, I'm going to, because they're negatives, I'm adding top 1, 2, 3. To keep it balanced, whatever I do to one side, do to the other. Take away any 0 pairs. Bye-bye. X is left, and then on the other side, it's equal to 9.
Wait, what?
Okay? Showing my work mathematically. Copy the equation. X minus 3 is equal to 6. Where I have the equal sign, I'm going to go slash. Okay? What did I do mathematically with the blue? I added 3. To get rid of subtraction, I add 3. To keep it balanced, I do it on both sides.
So x was 0, 0.
This cancels out. Those were my 0 pairs. X is equal to 9. Okay, when in doubt, solve it out. X minus 3 is equal to 6. And I think that x is equal to 9. 9 minus 3, does that equal 6?
Yes.
Absolutely. Okay, so I'm not going to assign this whole rest of the packet. Let's say, let me look at all of this. Let me look. Because we didn't get to as much in my class, on the you try, I want you to do 1, 3, and then the homework page. Okay, because we talked a little bit too much in this class. 1, 3, and the rest of the homework page. You'll have a great night.